All right, so how many of you got merge sort working? So we have 2.5 people got merge sort working. How many of you spent at least 5 hours in your homework? How many spent at least 8 hours in your homework? 10, 12, 15. All right, so we had some people at 12 hours. That's dedication. Now, I want you to reflect back on that experience. I mean, some of the weaker people only spent 4 or 5 hours. They gave up. It's like no hope. They look themselves in the mirror like, I accept defeat. Okay. Now, the important part of something like this is whether you spent 5 hours on it or 10 hours or 12 hours, you learned a lot during the process, right? Because you tried a bunch of different things, especially with recursion. So recursion is one of these things you really have to kind of experience in order to realize how bad you are at it. Eventually, I promise you will be good at it. But it's one of those things we kind of have to throw you into the deep end to appreciate recursion. The real kicker with merge sort, what makes it maybe more difficult to solve recursively, is that it kind of is a double whammy when you have 2 recursive calls next to each other. Your mind kind of gets into this weird twist, and you're like, what the heck is happening? Does that kind of make sense? Yeah. How many of you are still stuck in that mode? Yeah, well, that's good. This is good for your... if you got to the point where you got so frustrated with the recursion that you started questioning your major, you were exactly where you should be. I promise you. Okay, this is like trial by fire stuff. We go right back to the first day of class when we talked about how computer programming is kind of like a sport. Any of you who play sports, you've had some of those practices where the coach just give you these death drills, right? And you have no idea why you're doing this. How does this relate to football or basketball or whatever the sport is? But 5 years later, you look back and you realize that something you did during that was something that helped you today. Does that kind of make sense? Mm-hmm. Okay, so this was a death drill. And warm up for the hackathon.
All in one.
All in one, yeah. This is included in your tuition, people. You can't beat this. I mean, how many of you would have asked me to just do this to you? Just for the experience. All right. So, how much time do I have now? I don't have much time. I gotta start writing this thing. All right. So let's. Do I use Adam in here?
Yes.
This is starting great, right? All right. So, merge sort's going to require me to split my lists in half over and over and over again, right? Now, the first kicker that we need to figure out here, and I kind of already wrote it, is how do we figure out the half of the list? In fact, let me just take this to a different screen. All right, so in this particular case, begin is 0, end is 4, okay, in this little list. If we assume it's not sorted, I know we have already previously sorted this, but it's not the one list, so we're going to say it's not sorted. We're going to have to call merge sort on the first half of the list and the second half of the list. Now, it doesn't matter which half becomes the bigger half as long as we are consistent with our math, all right? So we need to figure out how do we get to the middle of the list. Now, we might be tempted to say, well, it's n divided by 2, right? We might be tempted to say the middle of the list is n, which is 4, divided by 2, which will give you 2. And in that particular case, that is the middle of the list. So we might be lulled into a false sense of security from that. So let's say we're going to split the list on that. And so let's say that becomes the new end, and then the middle plus 1 becomes this guy. So I'll split the list here. Now, let's pretend we're way ahead in the algorithm, and now we are dealing with begin is 3, end is 4. Does end divided by 2 give you the middle of this list? No. 2 is not even in this list. It becomes a problem. So really, we want the middle of this to either be 3 or 4, depending on whether we're doing the small half first or whatever. So 4 plus 3, so end plus begin, divided by 2, right? 7 divided by 2 gets you a what? 3.5. We either round up or round down. That gets us to a thing. So this would be the new end, and this would be the new begin 2. Okay, so it's end plus begin divided by 2. So we need to be able to calculate where the middle is. That way we can always operate off of it. So if we go off of that, so we'll say 4 plus 0 is 4, divided by 2 gets you 2. Now we have a decision to make, and whatever decision we make right now is the decision we need to stick with from this point forward. So that decision is going to be, does this middle, does that represent the end of the first half, or does this represent the beginning of the second half? Okay. Doesn't matter. Either one of those is viable as long as we always make the same decision. Okay, because if we don't always make the same decision throughout our algorithm here, you're going to start missing buckets. Okay? And if you run into that where you had a list that's sort of kind of sorted, but you had like these little stragglers in there that kind of got left behind. Okay, so that's something you need to look out for with merge sort, is something that can happen. Okay, so when we first go into merge sort, here's that end plus begin divided by 2. All right, and I decided in my version of this that would be the end of the first half. Make sense? All right, so how is this working to start off with? So we have merge sort, we're taking in a list. Presumably that list is unsorted. So as long as the list at least has 2 elements in it, we need to do something with it. If it only has 1 element in it, we're done. It's sorted, merge sort. All right, so if there's at least at least 2 elements in it, we're going to go ahead and have to calculate the beginning and end of the first half and the beginning and end of the second half. All right, so the beginning of the first half is going to be 0 initially. The end of the first half will be end plus begin divided by 2. So that's going to give us our middle point. The beginning of the second half will be whatever the end of the first half is plus 1. And the end of the second half will be the length of our list minus 1. Does that make sense? Go ahead.
Would N1 be integer division?
You would probably do that to give you the integer division. Otherwise, it'll give you a 2.5. So you have our begin 1, begin end 1, begin 2, end 2. So this is pointing to the beginning and ending of the first half, beginning and ending of the second half, right? Yeah. So then we're going to go ahead and we're going to call merge sort helper on the first half, passing it the whole list, passing it the begin 1 and end 1. And then we'll call, and this guy's going to go on for a while before we ever even get to this line. Because this guy here is going to have to keep dividing it over and over and over and over again until it finally gets down to 1 list and then bounces back up and merges those, and then bounces back up and merges those. So not until the list between begin 1 and end 1 is completely sorted will we even make our second call to merge sort helper. Does that make sense? Because this line blocks. Okay, when we call that line, we go on a voyage through recursion, and this guy doesn't return until, in this particular case, the first half of LST is completely sorted. Then we go and completely sort the second half of it. Then we do our final merge step. Make sense? Okay, so what I'm going to do here, so for merge sort helper, you wish the answer was just LOL. We want to ask, is this list already sorted? Or really, we want to ask if this list is not already sorted. So a sorted list we decided is a 1 list. How do we detect if something is a 1 list? Begin and end are the same?
Yeah.
Okay, so if begin is not equal to end, if they are different from each other, we're dealing with a list that is bigger than a 1 list. That is, we are dealing with a list that is not sorted. Make sense? So if I'm dealing with a list that's not sorted, what do? Divide the list in half. Call merge sort of the first half, call merge sort of the second half. Okay, so I'm going to go ahead and steal these variables. Really, what we did up here is exactly what we're going to do in here. This was just a helper that required us not to have to originally call merge sort, passing in beginning and ending of our list. So kind of a convenience for the end user. So merge sort helper. So inside here, I'm going to go ahead and just paste that stuff. I'm going to need to calculate the beginning and the end. So the left half, begin 1, is going to be equal to begin, right? The beginning of this current list. End 1 will be n plus begin divided by 2. Begin 2 will be n1 plus 1. End 2 will be not the length of the list, but it'll be end. So we're trying to pinpoint the beginning and ending of the first half of the portion of the list we're looking at, and the beginning and ending of the portion of the second half of the portion of the list we're looking at. Make sense? All right, so the beginning of the first half of this portion of the list will be whatever begin was. Begin was passed in here. The ending of that list will be middle, so n plus begin divided by 2. The beginning of the second list will be whatever middle was plus 1. And then the ending of the second half of the list will be whatever n was passed in here. Because we're potentially only looking at a little portion of our list. That's our entire world, right? All right. So I see some smiles here. So can you imagine how much damage 4 little integers did? 4 integers, right? You having trouble keeping track of those couple of places was the difference between being able to solve this and not solving it, right? So we're keeping track of the first and second half of this. So we'll go ahead and then call merge sort helper begin 1 n1, merge sort helper begin 2 n2. Now, when this if statement is done, when these two calls are done, let's start with this. What does this guy do? If you had to just explain in layman's terms, what does merge sort helper do to the values between begin 1 and end 1? Go ahead. Let's go higher level. What does it ultimately produce for me? Generically speaking, what does MS helper do? When I pass it the entire list and I pass it a range that I'm interested in it working on. Go ahead.
A single value. I go at the end of the single index.
When this call returns, what can I say about the values in LST between begin 1 and end 1? They're in order. So MS helper, its job is to put in order the values between begin 1 and end 1. Okay? So when this call to merge sort helper is done, begin 1 and end 1 we haven't written the merge portion yet, but presumably what this guy does is he puts those values in order. When this call returns, what he does is he puts the other half in order. Then what do? We do our merge step. That makes sense? Now we can write it in here, or we can go ahead and just maybe write it as a separate function to kind of keep things a little bit separate. So I'm going to go ahead and I'm going to say def, we're going to call this guy MS merge. Okay, MS merge is going to need the list. It's going to need a begin 1, an end 1, a begin 2, and an end 2. So from this guy's perspective, he's interested in doing a merge with those little pieces of our list. Right? All right. So now, what's the length of that new list that we're going to be creating? Because I'm dealing with values starting at begin 1 and going all the way up to and including end 2. So it's going to be N2 minus begin 1 plus 1. That's the length of the list.
Yeah.
Legal buckets being begin 1 through N2. Something along those lines. Now, what's nice in Python that makes this problem actually easier is I can just start with an empty list and start tacking things onto it. Now, if you remember from our design here, we kept track of the beginning of our first list and our beginning of our second list, correct? So our merge step here, we kept track of pos 1 and pos 2, where pos 1 went on a voyage between, I'm going to use other variable names now, begin 1 and end 1.
Mm-hmm.
Pos 2 went on a voyage between begin 2 and end 2. All right? And it was still pointing to a legal place as long as it was pointing to a place that was less than or equal to end 1 or end 2, depending on what the values were. All right, so in our merge step here, I'm going to say pos 1 is going to start off being equal to begin 1. We're going to say pos 2 is going to start off being begin 2. So I'm going to make my two little variables point to the beginning of each of our lists. All right. Then I'm going to go ahead and give myself my, my temp list. So I'll say temp list is equal to, we'll start it as the empty list. Now I want to fill up temp list with the winners between pos 1 and pos 2 from our original list, LST. So we're going to keep doing something while what is true? While pos 1 is less than or equal to end 1, and pos 2 is less than or equal to end 2. As long as, actually we're going to say or here. As long as one of these things is true, we still have a value to place. Okay, so as long, I switched the and to an or here. So as long as either pos 1 is not off the end of its half, or pos 2 is not off the end of his half, we have a winner to declare. So inside here, we'll ask a question. So we're going to ask if pos 1 is less than or equal to end 1, and pos 2 is less than or equal to end 2. If that's a true statement, that means they are both pointing to legal places. So we have a real competition, right? Mm-hmm. So then we'll ask the question, if LST at position pos 1 is less than LST at position pos 2. If pos 1, the guy at pos 1 is the smaller value, then we'll say temp list dot append LST at pos 1. Else temp list dot append LST at pos 2. So if they are both pointing to legal places in our portion of the list, then we'll ask the question, if the value at position 1 is less than the value at position 2, go ahead and tack that value onto our temp list. Otherwise, tack the other value onto our temp list. Now, if I have declared pos 1 to be the winner, I need to add 1 to pos 1. We've now burned past that value. If I've declared pos 2 to be the winner, I need to increment pos 2. Okay? So this is the question we ask. And now let's go back to basically the first day of class. How do human beings solve problems? Remember stuff, ask questions, and repetition. What's different about this problem? We're asking more questions than we've previously been accustomed to. We're remembering more values than we've previously been accustomed to. All hard programs are made up of a bunch of easy parts. So none of the individual lines of code we've written so far seem difficult. Mm-hmm. It's bringing them all together in the right order That's a challenge for us right now, right? I know that. Okay, and I take that into consideration when I grade stuff while I'm laughing and eating ice cream probably. All right, so this is the logic we do. So I start off by asking the question, if I'm looking at two legal positions, let's pick a winner and place the guy accordingly. Else if. Now, if I'm in this LF, I know that either pos 1 or pos 2 is illegal. So I can say if pos 1 is greater than n1, that must mean that pos 2 is the legal guy right now, right? So I'll go ahead and say temp list dot append list at position pos 2, and then pos 2 is equal to pos 2 plus 1. So if pos 1 is illegal, by default, we'll declare the winner to be pos 2 and increment pos 2. Otherwise, pos 2 must be illegal, therefore pos 1 is the winner. So temp list dot append list at pos 1, and then pos 1 is equal to pos 1 plus 1. Now, at the end of this while loop, what can we say is true? And I'll post all the code up on Slack. What can we say is true about temp list after this while loop is complete? Temp list has all of the values between begin 1 and end 2 in order.
Mm-hmm.
Now I need to stick them back into the original list in the right place. Mm-hmm. All right. So I'm going to be going through. So I'm going to start off. I'm going to create a little variable here called pos in temp list. I'm really exaggerating the name of this variable. Okay. I'm going to start that off at bucket 0 because temp list has legal values between 0 and length of temp list minus 1. But I'm placing those values into positions in my list, LST, between position begin 1 and end 2. Those might not be buckets 0 through 5. Those might be buckets 7 through 13. Make sense? So I'm going to have a for loop here that says for I in range between begin 1 and end 2 plus 1, because I want to go all the way up to and including end 2. And the range thing says go up to but not including this value. So by adding 1 to end 2 here, this will end up making I equal to that. Then each time through, I'm going to say list at position I gets the value of temp list at position pos in temp list. And then I'll say pos in temp list is equal to pos in temp list plus 1. So this variable is going to walk me through temp list from bucket 0 to bucket 1 to bucket 2 to bucket length of temp list minus 1. Whereas I is going to walk me through list from position begin 1 all the way up to and including position end 2. And each time through, I'm going to overwrite the value that's in list at bucket I with whatever was in temp list at the equivalent position, but possibly a different number. Go ahead.
Why couldn't you just return the temp list?
Well, because that's not what this guy does. The job of this guy is to overwrite portions of the original list. We're taking advantage of our knowledge that lists are passed by reference, right? I don't want temp lists. I don't want this, this extra thing that shows me what could have been. Okay, I'm holding on to this list like, oh, this guy looks perfect. I really wish that guy looked like that.
Yeah.
What we really need to do is we need to put those values back up there to make that guy look like that. Well, that's okay. this homework assignment was about the experience of going through something that was very challenging. I expected most of you to give me, well, I expected most of you to learn a lot through the process, but not necessarily be able to come up with a good solution to the problem because this problem is artificially complex. Does that make sense? Even though we're seeing it has a whole bunch of easy lines of code in it. If I asked you, anybody in here, what does that single line of code do? We'd all be able to answer that. It adds 1 to pos in temp list. No biggie, right? These are all easy lines that add up to something that's more, I guess, interesting. So what's the job of merge? Merge takes in my original list and then the ranges of the first half and the ranges of the second half and goes through and ultimately replaces the values in list between begin 1 and end 2 with those values in order. Okay, that's what this guy does. So after we call MS helper, our 2 times here, I'm going to call MS merge, passing it my list, passing it begin 1, passing it end 1, passing it begin 2, passing it end 2. I'm saying, look, here is my list. Here's the range of the first half. Here's the range of the second half. Put those in order for me. That makes sense? Now, if I'm not in this if statement here, I'll just go ahead for a second, just write an else. If I'm in this else, what does it mean?
Oh, if begin and end are equal.
Which means I'm looking at a 1 list.
Yeah.
Do I need to do a whole lot of merging for 1 lists? I don't have to do anything. It's already sorted. We're good. So there's no else here. MS helper will only do anything if I'm looking at a list that has at least 2 elements in it. Otherwise, it'll just bounce back. It ends after doing nothing. Okay? So then up here in merge sort, I'm calling MS helper in the first half. I'm calling MS helper in the second half. I'll make one last call to MS merge, passing it my list, passing it begin 1, end 1, begin 2, end 2. And when all is said and done, my list should now be sorted. Because this version of begin 1 and end 1 and begin 2 and end 2, begin 1 is bucket 0, end 2 is the length of LST minus 1. This was my original call to this guy. So that's going to merge those 2 guys completely together. So let's run this guy. I've been keeping this in downloads. Where do I keep this? Or desktop? If you're wrong, this is a 0 in the course. All right, let's see, what didn't it like?
Oh, that's on the first part.
Yeah,
Because we don't have an end defined
I
yet.
saw that too.
So we have to kind of more hard code and put end in.
Oh, I called it end 1, and so this guy would be the length of LST minus 1. And that'll get me N1. We also don't have a begin, so this would be begin 1. So I'm good there, right? So is that my stuff sorted?
Yeah. That is sorted.
So that is merge sort. Easy, right?
Something like that.
Wait. So close, but so far away from it.
But that's good. Why was a problem like this difficult for us? So we want to step back and we want to try to kind of self-reflect on where did our skills come up short for where they needed to be for this problem. How many of you drew a lot of pictures while you were solving this problem? That's good. The people who did solve this problem, I assume, drew lots of pictures.
The thing is that when I go through the Mergersort, like I know when it's end, but I don't know when it's go back up. Because you go through it so many times that I lose the point that I go back up to.
Okay. Well, so why don't we do this? Why don't we give ourselves a mixed up list here, and then why don't we walk through our algorithm and see what each line does? Trace it. We've seen this work, so we know that it works. Now we want to understand why it works. That makes sense? Because, I mean, this is kind of like a Rubik's Cube, right? You do enough permutations of stuff, eventually you get this magic solution. Like, wow. All right, so let's go ahead and we'll use this list here. So we'll do a 4, 2, 1, 7, 5. It's now completely jumbled up. This is the most sorted or unsorted list I've ever seen. All right, so it's going to be the easiest way to do this. Is there a way to hide this side?
Yeah, the little arrow in the middle.
Little arrow, and oh, this guy. Thank you. Star for the day. And then I'm going to hide this. Squeeze this over. All right. Let's go to work. Right off the bat, if we go all the way down here to the bottom, I'm calling merge sort, passing it my list. So this is my list up here, right? Mm-hmm. So let me create a little variable. Called my list. I'll scooch this guy over. And I'm going to have my list point to the beginning of this guy. All right, so my list points to that list. So now, and we're calling merge sort. So here's our call to merge sort up here. Merge sort takes in a variable called LST. So as far as we're concerned, we actually have a second variable here called LST that points to the exact same place that my list points to. Make sense? So these guys are synonyms for each other. They both point to the identical place in memory. All right, so now we ask the question. The length of LST, is that greater than 1?
Yes.
Yeah, I got 5 buckets here. We're good to go. So we're going to do some logic. So I need some variables. Begin 1, end 1. Begin 2, end 2. So let's give myself those variables. Begin 1, end 1. Begin 2, end 2. Okay. And just for the sake of remembering, this screen right here is going to be the result of calling merge sort on my list. So what I'm going to do is I'm going to create more slides to show us the recursion. Okay, so we have begin 1, end 1, begin 2, end 2. Begin 1 starts off at 0. So that guy's 0. End 1 starts off at the length of our list minus 1. So this is 4 plus begin 1, which is 0. So 4 plus 0 divided by 2 is 2. So that's 2 for N1. Begin 2 is N1 plus 1. So N1 is 2. N1 plus 1 is equal to 3. And N2 is the length of the list minus 1, the last legal bucket in the list, which is bucket 4. Make sense? All right, so there's all those guys. Now, I'm making a call to merge sort helper. So this function, this call to merge sort, gets put on hold. I'm going to go ahead and I'm going to copy this thing. So I have two different slides here. Here's my first call. This is ms helper. And I'm passing it LST here. Now, in the scope here, my list isn't even a thing, right?
Mhm.
Although, let's leave my list in there just to remind us that we are actually making changes to real memory. So this is ms helper passing it list and passing it our value of begin one and end one. So in this particular case, begin one is 0, end one is 2. Correct?
Yes.
Okay. So we're down here. So we'll go ahead and give ourselves a pause 1, a pause 2. Well, that's the merge, sorry. Here's ms helper. So we're going to ask the question, is begin and end different values? Is 0 and 2 different values? They are. So we're going to go and do this. So we're going to set begin 1 equal to begin. So that's going to be 0. End 1 is equal to end, which is 2, plus begin, which is 0, divided by 2. So 2 divided by 2 is what?
1.
1. Begin 2 is end 1 plus 1. So that's going to be 2. And end 2 is going to be equal to end, which is 2. Make sense? All right, then we're going to make our call to merge sort helper. Call to merge sort helper. So I'm going to copy this this guy. I'm passing merge sort helper the first time, begin 1, end 1. So it's going to be 0 and 1. That's the first call to that guy. Are begin and end different values?
Yes.
They are. So begin 1 is going to be equal to begin, which is 0. End 1 is going to be equal to end plus begin. So 1 plus 0, which is 1, divided by 2. How many times does 2 go into 1?
0.
0 times. Okay, so end 1 will also be 0. Begin 2 is 0 plus 1. And end 2 is 1. Then what do? We call merge sort helper. Put this on hold. We call merge sort helper, passing it a 0 and a 0. Is begin and end different values? They're not. They are the same value now. So I have nothing to do with this slide. Delete it. That function has ended. Now I'm back to this one. Now I'm making my second call to merge sort helper, passing it begin 2 and end 2. Begin 2 was 1. End 2 was 1. Are these guys different values? They're not. 1 and 1, same value. So this call is done. It's trivially sorted. It's a 1 list, so I'll delete this. So now we're back to this call where begin 1 and end 1 are 0 and 0 and 1 and 1. Now I'm going to do my ms merge. So I've passed this line. I've passed this line. Now I'm going to do my merge because the first half of this portion of the list, so we're looking at a 4 is sorted and a 2 is sorted. All right, so I'll call ms merge. It takes me up here. So begin 1, end 1, begin 2, end 2. I'm going to give myself my couple of extra variables here. So I have my pause 1 is equal to begin 1, which is 0. And I'll have my pause 2 is equal to begin 2, which is 1. Then we're going to keep doing something as long as something is true. What's the something that needs to be true? As long as pause 1 is less than or equal to end 1. Is that true? Is pause 1, which is 0, is that less than or equal to 0? Yep, it's equal to it. Or pos 2 is less than or equal to n2. Pos 2 is 1. Is 1 less than or equal to 1? It is, so we should get into this loop. So we'll go in. We ask our very first question. Is pos 1 less than or equal to n1 and pos 2 less than or equal to n2? These guys both point to legal positions on their list, right? Since that's a true, we'll come into this line. If the value at pos 1 is less than the value at pos 2. So pos 1 is 0. Here's our value at 0. Here's our value at pos 2, which is bucket 1, which is less. Pos 2 is less, right? So I'll give myself the little sample guy here. So I'll go ahead and put the 2 there. This guy's still empty. Then we increment pos 2. Spin back up. Is pos 1 still a legal position? Yep. Is pos 2 still a legal position? It's not. Pos 2 is now off the end of his list. But this is an or, so we're okay. As long as one of these is true, we're good to go. Then we'll come in here and ask the question, are both of them legal positions? They're not. So we skip that if statement. Is pos 1 a legal position? Or is pos 1 and this question really says, is pos 2 a legal position? Or is pos 1 an illegal position? Pos 1 is not illegal. It's currently a legal position. So we'll skip past this. We'll go to the else. We'll go ahead and choose our winner by default being whatever pos 1 points to. Pos 1 is 0. Bucket 0 is a 4. Put the 4 there. Increment pos 1. Spin back up to our while loop. Is pos 1 less than or equal to n1? Is 1 less than or equal to 0? Nope. Or is pos 2 less than or equal to n2? Is 2 less than or equal to 1? Nope. So both of these guys fail. That means this while loop is now done. So we move past this. We're going to keep track of our pos in temp list. So I'll give myself a new variable here. Pos in temp list. And we start this guy off at 0. I'll go ahead and move my temp list down here. Okay, because this is my temp list. Now I'm going to go through all the values. So I is going to be equal to begin 1 all the way up to n2. So we're going to go through our original list from bucket 0 to bucket 1. And all we're doing is we are copying into our list at that position temp list at position pos and temp list. So at bucket 0 here, we're going to copy in temp list at position pos and temp list, which is 0. So I'll overwrite this guy with a 2. Pos and temp list plus plus. I'll overwrite this guy with a 4. And now I'm done with this particular write. So I've changed my original list a little bit here. Make sense? Is this call now done? Now, one thing we do need to be careful of here, I changed this guy in memory, right? So that means 2 and 4 were changed here. 2 and 4 were changed here. Okay, yep. So now this call is now complete. Correct? So this guy will end. We'll come back up here. And this was the result of merge sort helper on 0 and 2. So we did our merge step. I'm going to copy this so I have it. Delete this. So now this call to merge sort helper is now done because we have finished merging. So now we're back up to merge sort on our, actually, hold on a second. Sorry. This first call to merge sort helper 02 is now done. So when we come up here, now we're at our second call to merge sort helper. Sorry, we're at this call to merge sort helper. So, because we're in MS helper still. So we're at our second call to merge sort helper, passing it our list and then passing it begin to and end to. So begin to is going to be a 2. End to is going to be a 2. We'll go through there. Same logic kind of goes down, right? Bucket 2 is sorted in and of itself, so we keep that at a 1. Then we do our MS merge. What will our MS merge end up doing? It'll end up saying this guy is a 1, this guy is a 2, this guy is a 4, which then makes that same change here. 1, 2, 4. So now this call is done. Bounce back up to the original. Notice the first half is sorted. So now we'll make our second call. So this is now back up here. This is our second call to merge sort helper, passing it begin to and end to. That's 3 and 4. So this guy will be a 3. This guy will be a 4. Are they different values? Yes. So begin 1 is 3. End 1 is going to be 4 plus 3 divided by 2, which is going to be 7 divided by 2 will give us a 3. This guy will be 4. This guy will be 4. We can already predict that when we call merge sort helper on this guy, it's not going to do anything because they're 1 lists. When I call merge sort helper on this guy, that's not going to do anything because they're 1 lists. Then we'll bounce back to this level. We'll call merge on this, which will put 5 here and 7 there. Then this call is done. Now we're back to our original call. This guy's complete. This guy's complete. Notice that the first half of our list is sorted. The second half of our list is sorted. Then we perform the final merge step, which will ultimately produce that. Then this call to merge sort has completed. We come all the way down to our main program. So this call to merge sort's done. And then when I go and print out my list, look what my list is pointing at. It's pointing at a list that's already in order. Does that make sense? All right, so I'll go ahead and put this code up on Slack so you have it to peruse. No homework over the weekend. We have the hackathon or penalty assignments, depending on which boat you're in. If you did not sign up for the hackathon, but you are around for at least some of it, I would encourage you to stop by the CS department at some point tomorrow between 8 a.m. and 8 p.m. And just check out, see how it works and things like that, because these are something we have every semester. And if you're in my class that semester, it's always going to be mandatory. All right? I will see most of you tomorrow morning, bright and early at 8 a.m.